Lesson 3-9 Practice Conditions for Triangle Similarity. Question 1. Refer to the triangles. What is the length of segment DF? Alright, we're trying to find DF, so we're going to translate point B to point F. We're going to rotate using center F, and we want this side 8 to line up with DF's, so the angle would be A prime FD, and then we reflect over DF, and you can see now the side that was 6 corresponds to 18, and the side that was 8 corresponds to DF, which we'll call X. And I think if you can see the answer, it's 24, but if you want to calculate it, 6 times X is 6X. 18 times 8 is 144. And 6x divided by 6 is x, and 144 divided by 6 is 24. Question 2. In triangle ABC, angle A is 35 degrees and angle B is 20 degrees. Select all triangles which are similar to ABC. The triangle sum is 180, and I think they said one of the angles was 20 and the other was 35. So that would make the third angle 125. So which ones are similar if they have two of the same angles? So 20 and 35, that's similar. There is no angle 30. 35 and 125, we just showed that. 20 and 125, yep. And 20 and 30, again, there is no angle 30. Question 3. Refer to the figure. Complete the explanation to determine whether triangles ABC and DEC are similar. By the blank theorem, there are two pairs of congruent corresponding angles. Alright, 180 minus 123 minus 36 is 21. Which is correct. So it's by the triangle sum theorem. By the triangle sum theorem, triangle angle sum theorem, there are two pairs of congruent corresponding angles, so they are similar by the blank triangle similarity theorem. Angle, angle. If two angles are the same of one triangle to two angles of another triangle, then they are similar. Angle, angle. Question 4. Lynn is trying to convince Andre that all circles are similar using the following justification. I can translate the center of any circle to the center of another circle and then dilate from that center by an appropriate scale factor, so they must be similar. All circles to be proven congruent, which is similar. You just translate the center point, and then you dilate until you have the same circle. So is Lynn's justification true or false? True. All right, I'm going to select this circle. I'm going to translate from this center to that center. And then I'm going to dilate by a scale from this center point by a scale factor of 2. And we have the same circle. Refer to the parallelograms. Which of the following explains whether these parallelograms are similar? All right, so you can see if you take the smaller one to the bigger one, you have a scale factor of 2/3 on each side. 6 divided by 9 is also 2/3. But it doesn't say that any of the angles are congruent. So they might be similar because the corresponding side lengths are proportional, but they are not. It doesn't say what the angle measurements. So we're going to pick one of these answers. They might be similar. Since we do not know if the corresponding angles are congruent, we do not. Yes, that is correct. We do know if the corresponding sides are proportional, so the last one's not correct. Question 6. This question has 2 parts. First answer part A, then answer part B. Complete the explanation to determine if the statement must be true, could possibly true, or definitely can't be true. An equilateral triangle and a right triangle are similar. So they can never be true because they have to have the same angle measurements. An equilateral triangle, all 3 angles are 60 degrees, and in a right triangle, one of the angles is 90. So that can never be true. Definitely can't be true. A right angle has a 90-degree angle in it, and an equilateral triangle cannot have a 90-degree angle. They can't be similar, as corresponding angles in similar figures must have the same measure. Complete the explanation to determine if the statement must be true, could possibly true, or definitely can't be true. A right triangle and an isosceles triangle are similar. Yeah, they could be similar if the right triangle is isosceles. So let's see, blank be true, could possibly. If the right triangle is blank isosceles, for example, a triangle with side units 1, 1, and the square root of 2, and a triangle with 4, 4, and 4 times the square root of 2 units. Question 7. Quadrilaterals Q and P are similar. What is the scale factor of the dilation that takes P to Q? So Q is bigger than P. So instead of 4/5, it would be 5/4. It has to be greater than 1. 5 divided by 4. 2.5 divided by 2 is also 5/4. Question 8. The circle centered at Q is a scaled copy of the circle centered at R. If needed, write your answer as a fraction using the form A divided by B. Find the scale factor. Well, if that's 5, 5 times 4 is 20. The scale factor is 4. Find the value of x. To find the value of x, you would need the Pythagorean theorem. A squared plus b squared equals c squared. Side A is 3, side B is x, and side C is 4. It's 5. Side C is 5. A was 3, and B was x. Alright, you can see there's 2 answers there. 4 and negative 4. Let's do the algebra. 3 squared is 9 plus x squared equals 25. We subtract 9 from both sides. We get x squared equals 25 minus 9 is 6. 16. And there's two answers that give you the square root of x squared is x, and the square root of 16 is 4 and negative 4. Alright, so we know it's 4, x is 4. Alright, marked one of them wrong. It says scalene, but I said isosceles. I must accidentally chose scalene.